welcome to Dave's Think Tank. I've been making some upgrades to these machines recently, and whenever I do something major like that, I feel it's important to keep tabs on how well the changes are working. So today I'm going to tell you about some recent changes and how I'm monitoring them. On the Star Trek, I had some major concerns over the amount of heat the machine was generating. I believe it was originally owned by an arcade where it was kept on for who knows how long, 10 or more hours a day. You can see here the results of the amount of heat that was generated by the power board was so much that it actually burned this plastic connector in half. So I've made a number of changes in order to cool down this machine. I've replaced all the playfield lights with LEDs, which are a lot cooler than the incandescent bulbs. The back glass lighting is now also LED and so much cooler. They're also much brighter, by the way, so I've removed a number of them. The displays are all LED, so I've removed the number of 2 fuse because the 190 volt circuit is no longer required, so I've eliminated that entire source of heat. So all these changes should make the machine run much cooler and much safer, but I also made a couple of changes which actually increase the concentration of heat. In another video I replaced the power board, and now the previous owner had moved the connector wires that caused all this burning. And while installing a new board, I reconnected those wires. So was I recreating the conditions that caused the original burn? The new board is better designed for heat distribution, and I used much better modern connectors, but who knows? The obvious test to perform here is to turn the machine on for a few hours with a thermometer inside and see how hot it gets. Except, having already made all these changes, I have nothing to compare the results to. Fortunately, I have the Vector, which is from the same time period, is extremely similar in design to the Star Trek, and still has all its original components. And I recently had to leave it on for 2 hours, and had the foresight to leave a thermometer inside. So how hot did the Vector get? Well, it went from 21 degrees Celsius to 32 degrees Celsius in 2 hours. For Fahrenheit fans, that's a mild 70-degree room temperature up to 90 degrees. Not enough to melt or burn anything, but a warning not to leave the machine on all day long. So how did the Star Trek fare with all its upgrades? I left a thermometer in the machine for 3 hours. This thermometer has Bluetooth, so I was able to track its progress on a minute-by-minute basis without opening the machine. The temperature began rising immediately, but not by much. After an hour it was up only 0.7 Celsius, and after 2 hours it was up 3 Celsius, compared to 11 for the Vector. So all the changes really seem to have made a difference. After 3 hours it was up only 3.6 Celsius and seemed to be leveling off. In Fahrenheit terms, it went from 70 degrees to 76, not particularly significant. So it seems there is far less need to worry than previously. Now I performed one more test that was not so positive. I used this forehead thermometer, which can be set to read surface temperatures, to test the new connectors in the area where they previously burned at the beginning and end of the 3 hours. At the beginning they were at normal room temperatures, but after 3 hours they were up by 11.9 Celsius or 21 Fahrenheit. Now this is still not in the range where we need to worry about burning. They didn't even feel warm to the touch, but it does suggest that it's still a good idea to leave the machines off when not in use. The second upgrade I want to test is the new memory capacitor I installed to replace the old battery in the Vector. When I installed it, I really had no idea how long it would take to charge, or how long it would continue to supply power to the memory chip, or how much power the memory chip required to maintain its data. My first test was on the battery I'd removed, which it consists of 3 1.2 volt batteries. That's a total of 3.6 volts, but the reading was more like 1.8. This is not surprising. It was 40 years old. One of the 3 is most likely completely dead. The other the other two severely reduced. Or maybe I just never left it on long enough for the batteries to get a really good charge, but this tells us that the chip will retain its data with only 1.8 volts. My second test was to search the internet for a data sheet on the memory chip supported by the battery. It says that a constant supply of 2 volts is required to maintain memory, which is likely conservative, as we already know that it has been working off of 1.8 volts, likely for years. My next test was to leave the machine off for a few days and periodically go in to check the voltage being supplied by the new capacitor. Touching the leads here and to ground with the machine off gives me a current reading of the voltage being supplied by the capacitor. I left the machine on for 2 hours to get the capacitor fully charged, and it read 5.4 volts. After being off for 3 hours, it was down to 5 volts, and after 24 hours it was only 4.4 volts. It seemed to be falling far faster than I had been led to believe, and might not even last a few days. But then it began to level off. After 2 days it was 4.2 volts, after 4 days it was 4 volts, and at 5 days it was still 3.8 volts. That was all I could stand, and I had to play the machine again. But it indicates the capacitor will work a long time without recharging. Maybe I'll go on vacation sometime and get a longer reading, but for now I know it's more than enough for my purposes. My final test was to find out how long it takes to recharge the capacitor. And the answer is surprisingly quick. At the beginning of the previous test, the capacitor read 4.2 volts, and I left the machine on for 2 hours, and it got up to 5.4 volts. But at the end of the test, 5 days later, when the capacitor was down to 3.8 volts, I only had to leave it on for 5 minutes to get it up to 4.7. We all have experience recharging batteries, and we therefore have some expectation that recharging takes a long time. But capacitors are very different and apparently only take minutes. So playing a few minutes a week is more than enough to keep your saved data safe with a memory capacitor. The final upgrade I want to test is my new targets. These were printed from my computer and attached to the existing targets with a plastic washer and a couple layers of double-sided tape. A visual inspection shows that there's very little, if any, damage to the images. The edges do not seem to be damaged by repeated hits from pinballs. But the big question is, do they actually stick? And the answer is yes and no. This row of 3 targets was the first added, and is under a constant barrage of direct hits from the flippers, but none of them has ever come off. The same with this 300-point target, but this 500-point target, which is far from the flippers and a difficult hit at all, comes off all the time. I replaced the tape a couple of times, but it made no difference. So I upgraded to a stronger double-sided tape. I replaced the original Scotch tape, which is really meant for wrapping gifts in disposable wrapping paper, with double-sided duct tape, which is meant for industrial uses. And yes, it is duct tape, not duct tape. This has been working perfectly for a few weeks now. One of my 4 vector targets was falling off as well, so I replaced all 4 with duct tape. But I plan to keep the 3 Star Trek targets on with Scotch tape just to see how long they'll last. One thing, if you decide to follow this advice, the backing on duct tape is almost impossible to remove unless you know the trick. Once the tape is laid down, and you've cut off the excess, peeling up the blue lining is almost impossible. So what you do, take your box cutter, just cut a slit towards any edge, and use your knife to peel up that edge. It should come fairly easily, and the backing comes off. So that's my update. If you have anything to add from your own experience, be sure to let me know in the comments.
Defender.